Welcome to today's lesson. I am Siamasaka Kirian Dens. I'm going to take you through a lesson in chemistry where we'll look at the GCSE and O level revision on the macromolecules, which is actually nylon in particular is the one we're looking at today. So we go straight into the lesson. Well, as you can see, the lesson we are looking at today is GCSE and the O level chemistry exam division actually concepts. And so we will look at polymerization. Generally, there are two types of polymerization. That is where you add actually the monomer units and then come up with a polymer. In other words, when you have a monomer plus another monomer, there can be several of them, you produce actually a polymer. And this polymer can be formed by actually addition polymerization or condensation polymerization. Addition polymerization is where actually the monomers are merely added without removing or forming another product, while condensation polymerization is where the monomers are added and at the same time you remove smaller molecules to form a byproduct. So that's the typical actually difference. In addition polymerization, you don't form actually a byproduct as a result of removing smaller molecules, while in condensation polymerization, you actually remove smaller molecules and you form a byproduct as you are forming a polymer. And so condensation polymerization is the one we are going to concentrate on today, where it is formed by the polymerization reaction, which is known as condensation polymerization. What is this condensation polymerization? It is where actually molecules join together while losing smaller molecules as byproducts. So the joining together here are the monomers. So the monomers, you join them together. You join together the monomers, and what you form actually is a polymer. And this process is known as the condensation polymerization because while joining together the molecules, the smaller molecules known as monomers, you are losing smaller molecules as byproducts. While in addition polymerization, as I indicated earlier, the monomers react to form a polymer without the formation of a byproduct. So this is actually typical difference between condensation polymerization and addition polymerization. But for today, we are concentrating on the condensation polymerization. And so condensation polymers are formed through condensation polymerization reaction, as I indicated, where we join together the molecules while losing smaller molecules. This is a typical actually repetition of what I've said earlier on. And so we have two different types of polymerization, but for today, we are going to concentrate on synthetic polymers. These are polymers which are not natural in nature. We make them, and therefore they are known as synthetic polymers. We have typically about 3 in our syllabus, synthetic polymers. Number 1 is nylon, which is also known as polyamide because it contains the amide linkage. It contains the amide linkage. The link between the backbones is associated with the amide linkage, and therefore nylon is known as a polyamide, while toluene is actually a polyester because it contains the ester linkages. It contains the ester linkages between the backbone, and therefore it's known as a polyester. We can include, though this is an addition polymerization, we can have also polyethylene. Polyethylene, which is a typical plastic, is actually also a synthetic polymer. But for today, we are not looking at actually addition polymerization. We are looking at condensation polymerization. And therefore, we are going to look at only one of these condensation polymers. And so, nylon is the one we're looking at today, which is a synthetic polymer. As we said, nylon formation, which is a polyamide. Synthetic polymer, it's a polyamide. When the monomers in the formation of nylon are combined together to form a long chain polymer, the process through which the monomers actually combine is known as condensation polymerization, because you are losing smaller molecules as byproducts in the process. These are typified by the amide linkage. As I indicated, you are going to find the amide linkage. There can be more than one monomer, unlike in addition polymerization, where you can have actually several monomers in condensation polymerization. But in addition polymerization is essentially using one monomer. And so we continue the lesson. Nylon monomers, one of the nylon monomers is actually hexamethylene diamine. Diamine because on either side of the backbone, so this is actually the backbone. So this backbone actually is associated with other intermediate compounds contained here. And so we are only concerned with the functional groups at the end, which are actually the amine. And so it's typically shown by a backbone and the amine linkage, where you have nitrogen linked to hydrogen on both sides. And because nitrogen has a valence of 3, and therefore it will have 3 bonds. So this is the diamine linkage, one of the monomers which is used to form actually nylon. You need another monomer. Another monomer is actually adipic acid. It's an organic acid. It's merely also going to have a different backbone altogether because the compounds contained here are different. But at the end here, it's going to have the carboxylic functional group, which is actually oxygen linked to hydrogen here, as well as the carbon linked to by 2 bonds to actually to carbon, and then you have oxygen actually linked to the hydroxyl group. And so this is the secondary functional group. It is associated with actually on either side of the backbone with the functional group, which is the carboxylic functional group. And so these can be actually combined to form the nylon polymer. And the process is very simple. You merely actually remove the hydroxyl functional group from the acid and the hydrogen from the amine. And then you form up what is known as nylon. I'm going to explain briefly here. What is shown here, I'm going to explain it briefly. And so you need the amine. This is the amine, diamine, because there are two. So on the other side, again, it has the amine. And this forms what is known as a monomer. And another monomer, there is the backbone. It has the carboxylic acid functional group. And the other side, again, you repeat the diamine linkage. Diamine on either side. And so for you to form actually the nylon, all you need to do is actually, as I indicated, you remove the hydroxyl from this, the acid, and from the amine, you remove it, you remove the hydrogen. Similarly here, you are going to remove this. Similarly there, you are going to remove that. Similarly there, you are going to remove that. And what you come up with then is the nylon molecule. So what you are going to have now is actually this side, you are going to have the nylon. It doesn't matter. This hydrogen can be down there. And then you have that one linked to that one. And again, so this is actually the amine monomer. And then you have this one coming from the acid, which is linked to the nitrogen. And then this is linked to the backbone on the nitrogen. And then here you have the nitrogen. Linked to actually the carbon, and so on and so on. So this is the nylon molecule that you have formed. This is the nylon polymer. So I was saying this process is known as condensation polymerization because we were removing the water as a byproduct, as you can see from here. And so this one is associated with the diamine, the amide linkage. And so this linkage, which is nitrogen, connected to carbon with a double bond to oxygen, and then the hydrogen. This linkage is known as the amide linkage. And therefore, nylon is known as a polyamide. Polyamide because it has several linkages, as you can see here. We have this linkage here, the second one, and the third one. So this is typically how actually nylon is formed from these monomers. As I explained here, I said the amide linkage. The amide linkage is actually typically for nylon is this one here. It is actually carbon linked to hydrogen and then the nitrogen. So this is the amide linkage in the nylon. This is the amide linkage in nylon, and therefore nylon is known as a polyamide. Very important. Okay, and so we now look at the exercise. Now, for you to do the exercise, you can contact me for solutions through my email address, which is ksiamasaka@gmail.com, or small letters, or +2609774199949 through WhatsApp. And so the exercise goes as follows, basically on nylon. And so the first question is from all these questions are from past papers, O level and GCSE. Which of the following is not a condensation polymer? This is the question. So you have to look at all these listed here, 4 of them. You look at one which is actually not formed by condensation. And the number 2, a polymer X is hydrolyzed and the 2 products are formed. These monomers are formed. So this is a monomer and this is a monomer. Hydrolyzed means that you had a polymer and you added the small units and it goes back for you to form again the monomer units. So which one of these? Is it through a condensation polymer, addition polymerization, starch, or terylene? So you answer this question actually. Third question, a macromolecule is made from the monomer molecules shown below. So these are the monomer molecules. And so what is the macro molecule? You have to tell us whether it is a carbohydrate, a polyamide, a polyester, or a protein. The second question, draw the 2 monomers of nylon. So you have to draw the 2 monomers of nylon as we have learned. Show the 2 monomers of nylon. Show the 2 monomers of nylon join to form the nylon monomer. So in other words, show how actually the 2 monomers of nylon join together to form the nylon polymer. Question 3, what is condensation polymerization? State the linkage found in nylon. State whether nylon is a polyester or a polyamide. State 2 uses of nylon. State 2 uses of nylon. This is a repetition, so we can cancel 1 there. Polymer Z has the structure, so this is the structure which is shown here. These 4 terms can be used to describe the polymer. 1, addition polymer, condensation polymer, polyamide, or polyester. Which 2 terms can be applied? So this is actually the exercise that you are supposed to do, and then you'll be able to